next question asked in 2013. In the arrangement shown in the figure, the stepped steel bar ABC is loaded by load P. The material has a Young's modulus E equal to 200 gigapascal, and the two portions AB and BC have area of cross section 1 centimeter square and 2 centimeter square respectively. The magnitude of the load P required to fill the gap of 0.75 mm is. Okay, so here this is the stepped steel bar. Okay, for this they have given this area of cross section is 1 centimeter square, and for this it is a 2 centimeter square, and E is nothing but 200 gigapascal. And here if you observe, at the point B, the force P is applied. So what happened because of this force P? This is elongating, and then it will fill this gap. Okay, that means the gap is 0.75. To fill this particular gap, how much force is required? Here nothing. What they have given? They have given the elongation, that is delta they have given. We need to find out the P. That is one point. And what is the other point? Is that delta is for the AB and BC together or only for AB? Okay, that is a tricky one here. See, as soon as you see this, you may think that the elongation is the total elongation for AB plus BC. But what is happening in case of the BC? What is the force that is applied in case of the BC? Is there any force in the BC? There is no force in the BC. Okay, for example, here what is happening? If I take this section BC, this is the B and this is the C, and here let's say this is a force P that is acting here, but here it is free to move. Nothing is restricting it. Okay, so there is no force at all. So whatever P that is acting here, it will cause the elongation only in the A and B. Okay, that means here P equal 0. The effect of P on the BC is 0. So here this is the area is nothing but P here in this case, and this is the P. There are no other forces. Okay, instead of gap, if you have a rigid wall, just touching the face C, then in that case, there will be some force that will be developed in the BC also, as like in the previous cases that we have seen. But since it is free to expand, there is no force on this. Okay, instead of applying this force P here, if I apply the force P here at the section C, then in that case there is a elongation in the BC also. Understood? Instead of applying at the B, if I apply at the C, in that case there is a elongation. Okay, you remember that. So but here in this case there is no elongation, that you need to identify that. So here there is elongation only in the AB. Okay, so delta is nothing but a PL divided by A into E. So what is the delta that is given? Delta is nothing but the gap, whichever it is there. So that is 0.75 mm. So we need to convert everything into the same dimensions, like 0.75 into 10 power minus 3. I am converting into the meters. Okay, 1 mm equal to the 10 power minus 3 meters, or 1 meter equal to 1000 mm, and P is unknown, that we need to find out. L is nothing but 1 meter here. So 1 divided by area is 1 centimeter square. 1 into, we need to convert into the meter. Okay, 1 centimeter equal to 10 power minus 2 meter, or 1 meter equal to 100 centimeters. Okay, 100 centimeters. So 10 power minus 2, since it is a centimeter square, it is a square here. And E is 200 gigapascal. 200 into giga mean 10 power 9. 10 power 9. Pascal mean Newton per meter square. Okay. So here P equal to, see here 10 power minus 9. P equal to 0.75 into, this one is 0.3 and this one is 0.4. So minus 7. I am adding these two. So 200 into 10 power 9. So how many? So what is happening? This 7, and here this is the 9. So only 2 are remaining. So here what is happening? 0.75 can be written as a 10 power square. Okay. Into 2, sorry, into 2. So it will become how much? 150. 150. Okay, this calculation you need to worry. So this is 15 kilo Newton. So what is the answer here? Answer equal to P equal to 15 kilo Newton, and which option is matching? Option B is matching here. Option B. See here, many times you may do some wrong, like here instead of writing this only for the AB, if you write for BC also, then what happen? You will get the P value as 10. Okay, then that is given in the option A itself. So you need to identify here. What we need to identify, since the force is applied at the B, so there is no force in the BC section. Why? Because there is no restriction. Here it is attached to the the fixed end, and you are trying to pull that away. Then in that case, what is happening? There is a resistance that is offered in the AB. But whereas in this case BC, since you are trying to push the BC and there is no restriction, then what happens? There is no resistance developed in this one. Okay, but whereas if you keep the same force at the point C instead of the point B, then what happens? You are trying to pull this C, then in turn the BC is attached to this portion. No, it is, and in turn this is attached to this portion. So it is it try to restrict in this direction, and this is also try to restrict if you are applying the force at the P. Then in that case there is some elongation in the BC and as well as in the AB. Okay, so it changes, the problem changes by the placement of the applied force here. Okay.